Welcome everybody, welcome to another video. This one is about the stars, celestial, astrophysics, and it's all connected to the flat earth model, because all truth leads back to the flat earth model when it comes to physics. Now, some of you may have heard of this new telescope NASA's got, or science. It's called the Rubin Telescope. And what it's about to do is reveal the secrets of the universe that show Earth is actually flat. And I'm going to show you how and why. Now they're not going to reveal all the images, or they're going to use the Rubin as a way to revert back to the truth and basically break down the fact that the Earth is flat and they got it wrong with something. I'm not too sure what they're going to do there, but there's billions of dollars to be made with the lie, with the globe lie, so I don't see them ending that lie. NASA's made billions and billions of dollars off it, and people, just the way they are, simple-minded, just go along with all that rubbish. So you few that watch my videos, I'm just going to show you something. And I thought I'd get in before they do it, just to show you that it's always been the flat earth model, and I've known it all. I don't even own a telescope. I've had the second-hand dunger. I threw it away, bought another one, that's just as bad, threw that away. I've got another one downstairs I'm about to throw away. Because I know all the physics and how everything works with the flat earth system, I don't have to go and visually see it. But with the help of some star trailing and that, time lapse, I've got to understand it all. So no one's really going to understand what's happening up there unless you get yourself a modern camera and start doing some star trailing and understand the two sky rotations and the celestial gap between the two rotations. Okay, so I'm going to show you some stuff here. Let's find my plate. You've got to understand the southern hemisphere sky and the northern hemisphere sky, okay? And they put them both together to create the globe model, which is a joke once you start understanding how it all works. So, like I say, you need to get yourself a camera to understand all this theory properly. You've got to understand the two sky rotation motions. In the northern hemisphere, they come out like this. All the stars they're doing a cycle basically, but you don't see all that. All you see is a massive stars, maybe on a slow motion circuit, 15 degrees per hour around in the north, and in the south we just see things coming around from our east, disappearing out to the west. So we'll see it arrive here, go over our horizon and disappear, when the whole system's forever revolving like this, just like this one's always revolving like that, because this revolution here is mirroring out to the southern hemisphere. But this southern hemisphere image is infinite. It's all the way around the centre north. Okay, sending out an image, a parabolic image into the night sky, because of the curving magnetic field of the southern hemisphere. Parabolic, sending a projection back to the observer of the rotation coming off here. It all comes from in here, this rotation in here. We don't see, because that's in the vacuum of space. You don't see light, or there's no sound, no light. So bear that in mind. So what's happening over the year at this point, this field here, magnetic field, moves up and overlays this northern hemisphere. Okay, so it comes up like this. So there's the Arctic centre here, and here's 66.6 degrees. This is the South Pole, 66.6 degrees. If you're like GP on the ground, the Earth, but the field itself moves up like this and overlays the stars in the north. It's this overlaying that creates the changing constellations. And then there it is here. Comes up like this and back again over the year. That's one tropical year. At the same time, this field here is moving around like this every day, 360 degrees a day, but 1 degree per day as it moves in, winds into the centre, then winds out again. And when it pops right out back to here, separated, is the 17th of October. That's when you get a sun image pop into the outer perimeter of the southern hemisphere, 24 hours. This is a long story. So we're concentrating on the stars today. So what I've done is I've created a glass, taken a big glass pane in a frame and made a support, basically like this. And I stand here and what am I doing? Well, I'm looking through here and I see the stars up here at night, and I mark them on my glass panel here. And each night, if you do it every consecutive, you go out every night, but you don't need to go out every night, go out every several days, but you've got to calculate the precession, which is 3 minutes 56 per day, per night. So if you go out on Tuesday at 11, or say 10 o'clock, well, on Wednesday you've got to be out there at 9:54 or thereabouts, 3.56 minutes. You know, reduce this amount every day and mark the movements of the stars again. So let's say there's the pattern. And what you want to do, you've got to, well, I'll get onto that in a minute, and mark the movement of the stars, and you'll find they've moved slightly like this. Okay? I'm speaking from my perspective in the southern hemisphere, okay? So the best time, I set it up for the 21st of June solstice, to start watching the stars recede back, because they're all starting to move back now, right? So this whole starry system is all moving back this way. So I actually had like some sort of triangle like this, and I'm aiming towards the celestial equator, or close to it, on the northern side. Okay, so south is all overhead, which is come up like this and then going back over me like this. So it's all receding back, and within a couple of days there are the stars exactly how I predicted them, moving slightly that way at the same time as going this way, 1 degree a day separation. Okay. So this is all you have to do. You don't need telescopes. Just keep your panel covered at night, because you're going to get condensation on both sides. You can wipe it off, as long as you don't wipe off your images. I've been using Sharpies, oil-based Sharpies, and I have several colours, so I can leave them up for several days, because I can see the different colours. Okay, so like I say, when they come together, they're forming their constellations and deforming. So these stars are drifting back this way in the tropical season, tropical year. At the same time, they're slightly drifting west, because it's the outer sync. It's this phi ratio overall, and then there's a state of equilibrium where they are the same. So the southern hemisphere there's a ratio difference here. I've just drawn them as equal there. But in reality, the southern hemisphere is bigger. And there's a bit of skew width, you see, they're off balance. So that drifts out of alignment. The only time everything is aligned and balanced is when the magnetic field is equal at the point of the sun's analemma crossover. These are the 5 holy days where the sun stands still, meaning it doesn't move in declination up or down. It's still going around every day, but there's no movement in this declination. It stays there. 2.5 days this side, 2.5 days that side in each season, going up and then come back down. So this Rubin telescope is going to be taking so many photos, they can't not see this. The stars coming up and then going back down. But you don't see it here. There's always this gap in the 2 rotations. So you think, how does this work? If you get this coming up like this, what happens here? Well, it'll be a separate video, but they talk about it in the Colburn Bible. It's under the veil. You just don't see the effect here. But these stars end up in here. And it moves up, right up. That star will end up right up in here. This star will end up here. It's a complete overlay. That's how the system works, okay? So you saw it here first. And one day these people will reveal the truth, hopefully. Or they're going to spin another story. I haven't put my head around how they would spin it on their globe theory. Because how do you take one overlaying system on their globe ball theory? It just doesn't work. Because this system here on their globe is the sun, is the earth flying around their globe, flying around their sun. Like this. So how are you going to show the star motion in their theory of a ball flying around the sun on a permanent tilt? Maybe they can, but it's just BS. Okay? Star movement. Anybody can do this. Go and do it. You've got to fix this. It's got to be fixed. Well, what I didn't draw is a little panel I put in here with an eye hole, because I've got to look through the hole. So I'm always looking at from the same position. Nothing's moving. Only the sky is moving. Okay, so I'm always looking through the same peephole at the view of whatever I can see, whatever stars I can see, and I mark them on the panel of the glass here. Okay, go and do it, people. You can go do it now because it's still drifting south. You can do it any time of the year, except after the 17th of October because it's completely separated then. So you want to catch it before then. You want to start, you could do it now right up until October, August. Stop at August. So it'll be way down here soon. About here is the Physica Piscis, and that's September the 6th, about there. So I think you know what I mean. There's your full overlay there, and it's going to be drifting away. So yeah, there's a cross section of the flat earth system, right? Put a slice through it. Your northern hemisphere, that little northern hemisphere. But this is drawn relative to the observer, so everything's equal. Back at creation, it's not equal. There's a small cycle, big cycle. That's where we get the sun analemma from. The only time you can tell there's a difference. It's like that. Okay? But this is relative to the observer, so it's all equal. So it's the physical world. So in the physical world, our two brain hemispheres, look, equal. Back here they're not. It's on a whole, that's regarded as our head. There's our body, head and body. Throat chakras or heart or whatever's in here. Okay. So you saw it here first. What do you call it? We go the tropical cycle star overlays. Tropical cycle star overlays in declination, eh? Declination. And then you come up here, that form and deform the, that pen's dying, constellations. World first, you've seen it here. Remember my name? Come up here, Patreon, Tomb of EL-lumination. Learn a lot more than what I've got here, guys. So if you like this sort of thing, put a likes up, subscribe, and don't forget to share it to as many people as you can. Otherwise, no one's ever going to know anything.